How's it doing here? In this video, I'll be making a way to keep your play in bounds. Although this won't work for all genres, it's a bit better than using 2D colliders, as it is possible to get out of a collider. Although 2D games are harder to go through colliders, it is possible. However, with this design, it is impossible to go out of bounds, as you see here. If we move too far to the top, it teleports us to the bottom. Too much left, to the right. Too much right, it goes to the left. So as you see, it's totally impossible for the player to move out of bounds. Okay, so as you see here, I'm just using a few assets from the asset store. I'm using the 2D Pixel Spaceship 2 Small Ships pack. As you see here, if we go to ships, as you see here, I am using ship 2, and although this pack does include fireballs, I'm not using them as project for now. Okay, so without further ado, let's begin. Okay, so in this video, we're just going to press play quick. As you see, we have a player, it's moving fine, however, it can go out of bounds. So in this video, we're going to fix that. So to start off with, I'm going to right click, create a C# script, and I'm going to name it Keep in Bounds. I'm going to go to my square, actually it's named Player, good. Okay, there we go, let's drag it on. As you see, I've got Player Controller, let's just close that quick, and we have Keep in Bounds. Okay, so let's go in Visual Studio Code quick. Okay, let's just delete all the functions. I'm going to make a serialized field. I'm going to make a float, and we're going to have left bounds and top bounds. That's it. Now we're going to go update, and I'm going to have an if statement. If transform dot position, okay, dot x is smaller than the left bounds, or if transform, let's actually just copy this, bounds is greater than negative left bounds. Now we're going to go transform dot position is equal to a new vector 3, because a transform dot position is a vector 3 of the x, y, and z. And we're going to make that on the x. Okay. We're going to just flip it basically. That's negative transform dot position dot x. So we just flip it. That's why it will work for this and this, because we're just flipping it. And then y, x, y. And this time these are not flipped. And finally Z. Good. Okay, there. Now we can go semicolon. Okay, and let's actually just log this quick. And let's call it teleport. Okay, let's go Unity quick. And now what we can do is if we go player now, so now we have left and top bounds. Okay, so the top bounds, the left bounds are negative 12.5, and the top bounds are negative 5.5. Okay, so now what we can do is if we go here, we just turn, move there, and as you see, it appears from the other side of the screen. And it can just transition smoothly like that. Now let's just quick, and also if you see here, we have our teleport debug, so we know it's working also there. Okay, let's just hook up the other side in Visual Studio Code quick. It's pretty much identical. We're just going to copy all this then. Okay, change x to y and y. Instead of having left bounds, we're going to have top bounds, of course, because we're doing y, which is the top in 2D. Okay, new vector 3, instead of making it negative x, we're going to make it negative y. Okay, so now if we go Unity quick. Okay, if we press play now, then if we move there, we should move there. If we move there, and there we go. As you see now, no matter how much a player will try, it cannot get out of the bounds. So no matter what it does, it will eventually come out on the other side. Okay, this is the end of this episode. I hope you enjoyed it. Bye!